title is on the board. Go ahead and write your title down. Remember, I asked you to leave a little bit of space so that you could write your title down. No, not while I'm teaching. One goes at the top, one goes in the middle, so we have space to solve, John. This is not our first time gluing in stuff. Those are way too close together, Bryson. You do not have enough space to solve. Once you've gotten them glued down, make sure we've got our title. Our title is on the board. No? All right, so your title, which should be at the top, says Associative Property of Multiplication. John, glue it in your notebook, please. Yes. That should be written at the top of your page. Associative Property of Multiplication. All right. So we know what multiplication is. We've talked about that for many weeks. I think you guys are pretty good at multiplication. So now what we're going to be talking about is a special math rule. We've learned about properties before. We know about the commutative property where we can rearrange those factors and our product ends up the same. This is similar to that. Go ahead and circle it. Associative property. You actually learned to do this with addition. No one just told you that's what it was called. But you do this with addition all the time. This is where you can group any factors. Those are parts of our multiplication equation. Back one. And still get the same product. We're going to look at some examples, but I feel like examples make a lot more sense when we have a story to go with it. So that's why we've got these word problems, because those are going to give us a story so we can really see what's happening. Yes?
Can we learn how to do this with subtraction?
No, you cannot do this with subtraction. You can't do it with subtraction, just like, remember, we can't do commutative property with subtraction because it doesn't give you the same difference. Yeah?
Subtraction, you can't really do it with subtraction.
Yeah, you can do the fancy tricks with addition, and we can do the fancy tricks with multiplication, but subtraction you cannot. You just have to do it exactly how it is. We can't rearrange it. Colby? Can you do what? No. And we'll talk about that as we get into division. Yeah? Kind of. They are inverse. Alright, so let's turn to our first word problem. It doesn't matter where you glued it in, but we're going to start with the one that says Diego has 5 pencil boxes. It should be the first one. So go ahead and find that problem, please. Let's start by reading it. It says Diego has 5 pencil boxes. Each box has 3 packs of pencils. Each pack has 2 pencils. How many pencils does Diego have? There's a lot happening. A lot happening. I'm going to read it one more time. I want you to think about what's happening. Diego has 5 pencil boxes. Can you imagine what 5 pencil boxes look like? Okay. Each box has 3 packs of pencils. Can you imagine 3 packs of pencils?
Wait.
each pack has 2 pencils. Can you imagine each pack having 2 pencils in it? All right. What am I counting in this problem? Shut up, Jalen. What am I counting in this problem? Keegan, what am I counting? Oh, I'm not counting pencil boxes. Look at your question. What does the question part say? How many pencils does Diego have? So what are we counting? Pencils. If I'm going to answer this question of how many pencils does Diego have, I need to know how many pencils. Write an answer sentence. Write an answer sentence. What could be your answer sentence? What could you have written? Huxley, what'd you write? Diego has blank pencils. Anyone else write that? What else could you, written? Evelyn? He has blank pencils. That'll work. Stick a little pronoun in there instead of thing. Ariana? Blank pencils and all. That'll work. As long as you have something similar, that will work. John? All right, let's make our bar model. Go ahead and make your bar model. I like to start with my whole or my total. Right, so what's the thing I'm counting again? Pencils. Does it tell me the total number of pencils? No, it doesn't. Doesn't tell me the total number of pencils. Put a question mark next to my whole. I don't know the total number of pencils, but I know some stuff. What do I know? What do I know? Macklin, what do I know?
You know that he has 5 pencil boxes and every pencil box has 3 packs of pencils.
Yeah.
And there's 2 pencils in each box.
Yeah. That's a lot of stuff that we know. Let's go ahead and separate our bar into our 5 pencil boxes, because we know he's got 5 pencil boxes. So far, so good? Do we see our 5 pencil boxes? Kaden? So are we thinking about the packs of pencils now?
Yeah.
Where are the packs of pencils? Where are they?
In the pencil box.
Do I have pencil boxes?
Yes.
So I'm not going to need another section of bar, but I'm going to have to put them inside my pencil box. So I'll show you what that looks like. How many pencil packs does each box get? Sit up. Keegan? 3. I'm going to draw 3 pencil packs. I'm doing circles because, just like Kaden said, I've got more stuff in those packs. Does that make sense? No, it only says each box has 3 packs of pencils. So there's all my packs. No, you cannot write 3. Because it's not just 3 packs. We now know what's going on inside of those packs. What's happening inside of those packs? Jalen?
There's 2 pencils in each pack.
So in each of those circles, now we need to write 2. that makes sense why we didn't write 3 now?
Yes.
Let's
look at the 5. That this is like like as in where it's like 5 weeks of 3 weeks is 3.
Yeah, this is going to be one of those really long equations. Colby?
Can we just put 6?
Sure, but this picture better matches what's happening, but yes, you can skip that step. So now we need to make an equation. This is where it gets tricky. Let's start with my pencil boxes. Are my pencil boxes groups? Are they just adding to something? Are we taking away something? What's happening with my pencil boxes? Zach?
There's 2 groups.
There's how many groups of pencil boxes? Pencil boxes. Pencil boxes. Look at your problem. Okay. So I have 5 groups of, can I put 3, because those are my packs, 3 groups of 2. Whoa, that's crazy. Let's make sure we know where these numbers came from. Where is that 2 coming from? Where is that 2 coming from? Right here. Yeah? No. No. The 2. What does that 2 mean? How many pencils are in each pack? What does this 3 mean? Kaden? Packs of pencils. What does this 5 mean? Again, I suggest you pay attention. Madison? Pencil boxes. 5 groups of 3 groups of 2. Evelyn?
Can I tell you the way I figured it out? Because it's really easy.
We haven't solved anything.
I know.
Okay, well,
I can show you.
when we get to solving, yes. Is there another equation? Is that what you're saying? Go for it. If you give me another equation, I'm not looking for a solution yet.
Put it in, put 5 times 3 in parentheses.
Sure.
And then times, and then times, and then multiply those, get the answer, and multiply that by 2.
Sure. Now, Colby said, hey, couldn't I just figure out the number of pencils first? Colby wanted to put 6 in this box. Because I'm assuming, Colby, you know that 3 groups of 2 is 6, right? So Colby did this. 5 groups of 6. Will that work?
Yeah.
What if we did it Evelyn's thought? 5 groups of 3, groups of 2. And did 5 groups of 3 first. What's 5 groups of 3 worth?
59.
Ooh. 15 groups of 2. Let's see if those are worth the same. If you're playing with your pencil, you're going to have a very hard time doing this by yourself in about 10 minutes. So I highly recommend you stop doing that. Five groups of 6, what's that worth? Y'all can do that. Got those 5s. Yeah? 30. So if we do it Colby's way, we get 30. If we do it Evelyn's way, we got 15 groups of 2. What does that work? Or 2 groups of 15? 30. Hey! Why did that work? Why? Colby and Evelyn had 2 very different ways. Why did that work? It's not magic. Feels like magic. They're magical. But it's not magic. Why did it work? Kaden?
Because of the associative property?
Yeah, because I've got multiplication and multiplication. If it was addition and addition, I could do the same thing.
What about addition? Times and addition.
No, kinda. Here's why. When I multiply, that's much more powerful than addition. So I have to do the more powerful one first. Does that make sense? You don't have to know, that doesn't have to make sense right now. It's technically a 5th grade thing. But it's called order of operations. You might have heard of that before. Yeah, so that just means that you do the most powerful stuff first, and then you move on to your weaker stuff. Multiplication gets you way bigger numbers than adding. So multiplication is more powerful than adding or subtracting. So if you have mixed, if you have addition and multiplication, you got to do the multiplication first. Does that make sense? So you can't quite do that. Jalen?
You have to still do the multiplication first, even though the adding it goes to a bigger number?
Yes. Because multiplication is just a more powerful operation. It's like a more powerful wizard. Alright, let's try another one. I know this is tricky. There's a lot happening. Now you could have gone this morning. I have a rule you cannot go while I'm teaching. Find problem number 2. Says at a farm stand. Find that one.
My daddy fell off and my orange is still there.
I'm sorry. It says at a farm stand, Jess sells 2 bags of 3 ears of corn. Do you know what ears of corn are? Ears of corn. Because we're going to need to know what ears of corn are if we're going to solve it. Right?
Ears of corn are kind of like a stupid.
Yeah, it's the whole thing that you would eat. So like if you get corn on the cob with the leaves, that's an ear of corn. That's what it's called. It's like a piece, the whole thing of corn. Have we had corn on the cob before? Or seen it at least?
My dog tried it.
Okay, so that's called an ear of corn. That's what that's called. So she sells 2 bags of 3 ears of corn. Her dad sells 3 bags of 2 ears of corn. How many ears of corn do they sell? What am I counting? Read that problem again. What am I counting? Everyone can tell me what they're counting. There's no math involved. You just gotta tell me what they're counting. Macklin?
Ears.
Yes, we're not counting people ears. That would be weird. Ears of corn. So our answer sentence. They sold people ears? Ooh, they sold blank ears of corn. We're counting ears of corn. Get that answer sentence down there, please. We know what we're counting. Ears of corn.
Is that the meat or is it like how is it?
No. Carla?
This is sounding like 2 different trades because there's 2 different people.
Ooh! Did y'all hear what Ronald just said? Ronald, say it one more time.
There are 2. It feels like there is going to be 2 different equations because there's 2 different people doing it.
Yeah, we've got 2 different people. We've got Jess and we've got her dad. Let's go ahead and make them 2 bar models. One for Jess and one for her dad, because we've got two different people. So I'm going to make my Jess, I'm going to put a J next to it. And then I'm going to scoot down here and make one for dad. I'm going to put a D next to it for dad. I don't care. Whatever makes your brain happy. Mackenzie, what am I counting?
How many ears of corn?
Do I know the total amount of ears of corn? No. Do I know it for Jess?
No.
Do I know it for dad?
No.
I don't know either of them. Let's talk about Jess first. What's going on with Jess? Jess sells 2 bags of 3 ears of corn. How would I put that in my bar? What is that going to look like? 2 bags of 3 ears of corn. Right?
Let's do break the bottom part into 2 halves.
Why? Why am I breaking it into 2 sections?
Because it says 2 bags.
These are my bags. And then what's happening?
And then you're gonna put 3 ears of corn.
3 in this bag, 3 in this bag. So far, so good?
Yep.
Happy? What equation matches that? I should see lots of hands. You should be able to tell me what equation matches that. Madison, start paying attention, please. Mackenzie? 3 plus 3. That'll work. Can you give me a multiplication equation? Ariana? 2 groups of 3. Ooh. Let's go down to dad. What's going on with dad? Madison, what's going on with dad? How am I going to draw that? Like, how do I show that on my bar model? Okay, we're going to split it into 3 sections. Why are we splitting it into 3 sections, Madison? Nope. There's also 2. 3 bags. Those are my groups. The bags is the important piece. Okay, now what? So we're going to put 2 in each section. 2 in this bag, 2 in this bag, 2 in this bag. Let's get an equation. What equation matches that? Zach?
3 times 2.
3 groups of 2. All of this, beautiful. But I can make one equation to solve the whole thing.
Oh,
And you can too. Because on the EOG, you're going to know all of this. You're going to be like, awesome, I got it. And then you're going to look at these equations and you're going to be like, what is this? Because they're going to make one equation that will solve the whole thing. And you can. You've got the pieces. We've got to put it together. Evelyn, you think you know?
6 times.
Nope. Nope. Don't try to skip ahead. Use the pieces that are right here. Tegan, you think you know? Nope. Nope. We're not solving anything. Rylan? Nope.
What's the question again?
I need one equation that solves the whole thing. Remember, it says they. So I need to figure out what Jess sold and Dad sold. Right? So far, so good? So I need Jess and Dad to get my total. So far, so good. Well, What equation works for Jess? What equation works for Jess? What equation works for Jess? Jalen?
2 times 3.
2 groups of 3. There's Jess's section. What equation works for Dad? Bryson?
3 times 2.
3 groups of 2. What operation do I need to do to make sure I'm getting the total between those 2? Kaden?
Plus.
Yeah, I'm going to add. This equation right here will solve the whole thing. Do you see it? Look at it. It'll make sense eventually, but you got to give it time to think about it. 2 groups of 3. That's what Jess had. Plus what Dad had, and he had 3 groups of 2 is worth. Now, yes, we can make this shorter. Rylan started to solve some of this. What is 2 groups of 3 worth? Just say it.
6.
Plus, no, is it times or plus? Plus 3 groups of 2.
6.
So 6 plus 6 would solve it. So I am not stressed. You know what to do. I know you know what to do. I'm making sure you don't get tricked on the very last step. Because I know you can do this. Yes? I know, Jalen, absolutely not. You can do this. I don't want you to do all this hard work and then get tricked because this looks scary. It's not scary. We know where those numbers came from. Last problem. What?
2 times 6.
So far, so good? Go ahead and read it. That T word is tamale. Nope. Tamale.
What's the one after the cart?
Sophia. It says, at a tamale cart, Sophia buys 4 packages of 2 tamales. Alex buys 2 packages of 4 tamales. How many tamales does each person buy? What are you counting? Tegan? Tamales. You know when you go to the Mexican restaurant, you order tacos, the quesadilla, that's a Spanish word, and you get Spanish food, Mexican food. Tamale is a Spanish word. You get a Mexican dish.
I don't know what the answer stands for.
What am I counting? Tegan, did you tell me what we're counting?
Yeah.
What is it? Tamales. Answer sentence. Right one.
I don't know what. We need 2 beans and
You could make 2. Or there's a word in there you could use that you didn't have to make 2. No.
I don't know this good.
Tamale.
Each person buys.
Each. You could use each. What could your answer sentence be? There's options. Doesn't have to be this one, but what could it be? Madison?
They buy link tamales and all.
It's not going to be they, and it's not going to be an all. It's not what my question's asking. Look at that question carefully. Jalen, that requires you to look at your notebook or look at the smartboard. Rylan?
Each person buys like tamales.
That'll work. Use the words from the question. Each person buys blank tamales. Rylan didn't even have to think of any new words. Sophia buys blank tamales. Alec buys blank tamales. That question is not asking how many they buy in all. It wants to know how many each person buys. Let's see.
Is it okay if I buy instead of buying?
Yeah, that's fine. Gia? Okay.
Sophia and Alec buy blank tamales.
As long as we have that word each in there, not total, that'll work. Okay? So far, so good? How many bar miles do you think we're going to need?
One.
Why don't we think about it in our head before we just say it out loud? Why don't we think about it in our head before we just say it out loud? Zach? Two. Why?
Because there's
Two people. Go.
why were some people saying
Make 2 bar models. One for Sophia and one for Alec. One for Sophia, one for Alec. So far, so good? Actually, what's the thing I'm counting again? Tamales. Does it say on my problem the total that Sophia bought? Nope. So question mark for you. What about Alec? Does it tell me the total Alec bought? Nope. Question mark for you too.
which has a number?
It does tell us stuff. What stuff we got? What stuff are we working with? What stuffs are we working with? Mackenzie, what's something it tells us?
Sophia buys 4 packages of 2 tomatoes.
So how's that going to look on my bar model?
4 spaces for 2 in each one.
Beautiful. Make those 4 spaces. Mackenzie, why did you make 4 spaces?
Because it says Sophia buys 4 packages.
Yeah, our packages are our groups. What's going inside those packages? 2. Can I just put 2 right here and be done?
You guys put on.
No, all of them. 2 are in all of them. She did not buy empty packages. I would be really sad if I got empty packages.
Yeah, that's not right.
Keegan? Yeah. All right. Tegan's telling us to make 2 parts for Alec. Why, Tegan? Yep. 4 in each. Beautiful. I want you to write an equation for Sophia, an equation for Alec, and answer the answer set.
Can it be multiplication?
You choose, John. Doesn't have to. It could be addition, but multiplication would work. Pick your poison.
Do we have these numbers?
The numbers in the problem?
Yeah. Yeah, but at the top too. Yes.
So again, reminder, was asking for the total, is asking each person. So it's not 16, because that would be total together. Each person bought 8. So far, so good?
Well,
Okay.
you bind us both together, you get 16.
Yes. We're going to spend some